In this question, we need to find the maximum value of small m. That means maximum value of this hanging mass, so that system will remain at rest. First of all, let us make the free body diagrams. First, consider free body diagram of small m. The weight of small m in vertical downward direction and tension force on small m will act in the vertical upward direction. And it is given system is at rest. That means there is no motion of the system. That means no motion of the block in the vertical direction as well as in horizontal direction. Vertical force mg is balanced by capital T. If it is not moving in the horizontal direction, that means horizontal force acting on a small m should be 0. That means no horizontal force should act on a small m, and only one possibility of the horizontal force on a small m is the normal reaction. It means normal reaction between capital M and small m should be 0. If normal reaction is 0, that means friction force will be 0. There should not be any friction between the surface of capital M and small m. Okay. Now consider free body diagram of capital M. Weight of capital M, capital Mg in vertical downward direction, and we know string is light inextensible. That means tension in this part of the string should be capital T and capital T here also and here also. So let us make the tension force capital T at this point also, capital T and capital T. Okay. Now normal reaction. Normal reaction will act in the vertical upward direction, and friction force oppose the sliding tendency. That means friction force between capital M and small m should act in the leftward direction. Small m, static friction. Now again consider the free body diagram of small m. We can write the vertical equilibrium equation capital T equal to small mg, first equation. Second equation we can write for the horizontal equilibrium of capital M. We can write small f equal to capital T plus capital T plus capital T. That means small f equal to 3 multiplied by capital T, and we know capital T is equal to small mg. That means this small f equal to 3 multiplied by small mg, second equation. Now let us write the maximum possible value of small m. That means friction force between the block capital M and ground. The maximum possible value of this friction force we can write, this is the coefficient of friction, so we can write mu2 multiplied by n. This is the limiting friction value. This is called the maximum friction force, and we can write n is equal to capital Mg plus T. So this is capital Mg plus T, and we know T equal to small mg. Now we can write the maximum possible value of the friction force. We can write F max equal to mu2 multiplied by capital Mg plus T. So this is the equation of the maximum friction force between the block and ground. We can substitute the value of capital T, small mg, g we can take common. So we can write here this value as mu2 multiplied by capital M plus small m multiplied by g. This is the third equation. And we know friction is static. If friction is static, this friction force, that means real value of the friction force should be less than the maximum possible value of the friction force. That means F should be less than or equal to mu2 multiplied by capital M plus small m multiplied by g, because friction is static. And we know small f equal to 3 multiplied by small mg. So let us substitute the value of small f. We are interested to calculate the value of small m, so we can rearrange. G and g will get cancelled. So here we can write this is 3m minus mu2 multiplied by small m, that is equal to less than or equal to mu2 multiplied by capital M. Okay. Now we can take small m as common. So this is small m multiplied by 3 minus mu2 should be less than or equal to mu2 multiplied by capital M. It means we can write small m should be less than or equal to mu2 multiplied by m, capital M, divided by 3 minus mu2. Now we can substitute the value of mu2 and capital M. Capital M we are given 8 kg and mu2 we are given 1 by 3. So let us substitute these values. Now we can calculate. Denominator is 9 minus 1, that is 8 by 3, and this is also 8 by 3. That means this value is 1. It means m should be less than or equal to 1. It means the maximum value of small m should be 1 kg. That means third option is correct option.